Last Friday, July 19th, there was an unmitigated computing disaster. An update ran amok on Windows machines across the globe. Now, I'm not here to do a postmortem. There will be lots of those, and it's not really on brand for this channel. I'm here to talk about some of the things that should have happened but obviously didn't, why that's inexcusable, and some techniques that you might use to avoid this kind of problem on your own projects. At this point, I'm supposed to smash cut to the channel intro. Today, though, that would be unnecessarily cruel and triggering, but branding is branding. So here's your warning. If you're one of the unfortunate souls who were directly affected by that outage, I recommend you put your fingers in your ears, close your eyes, and count to 5, starting in 3, 2, 1, now. This is the Internet of Bugs. My name is Carl, and today we're talking about the outage last week. They grounded planes, took financial systems offline, and brought big chunks of the internet to a screeching halt. Coincidentally, at least as far as you know, my video earlier last week talked about a study that showed that 90% of catastrophic computer failures were caused by poor error handling code. This catastrophic failure was one of those, likely in more ways than one. First, a quick high-level recap to set the context. Basic facts as I understand them at the time of writing, Crowdstrike, I don't know why I have so much trouble saying that. So Crowdstrike sent out an automated update to their Falcon security product, which is used by a bunch of businesses to secure their computers and their data. That update caused many machines, lots of machines, to blue screen crash on every boot up thereafter. The fix requires someone to manually bring up each and every affected machine individually, in safe mode, delete a .sys file from the Crowdstrike directory, and reboot. That's annoying if you're fixing your own machine, assuming that you have a different machine or a phone from which to read the instructions, and you have enough privileges to follow them. But imagine the largest retail store you've ever been inside. Now imagine that every single aisle of shelves of product was replaced with narrow cabinets, taller than a person, that each has dozens of individual servers in them, each of which has to be fixed individually. Now, some of those cabinets will have complicated, expensive, finicky little setups that were previously installed that might allow machines inside to have their consoles accessed remotely. Based on my experience, though, most of them probably will not. And for those, some poor sucker has a cart with a monitor and a keyboard and a mouse on it. And they're rolling that cart from cabinet to cabinet and plugging in each server individually with the monitor, the mouse, and the keyboard, one at a time, and fixing it. In an 8-hour shift, they might be able to fix 500 machines, which might be 8 or 10 cabinets worth. And keep in mind that many of these machines can't just be booted into safe mode without having an admin person type in some specific password and or decryption recovery keys. Some of those decryption keys will have been misplaced, or they won't be available because they were stored on a machine that was also broken by the bad update. The effects of this update failure are basically indistinguishable from a mass ransomware attack, with one minor exception. This time, instead of having to pay the perpetrators to get back your machine and your data after the incident, you've already been paying the perpetrators that caused the problem for the privilege of letting them do this to you. Now, let's talk about why this happens. The biggest reason this happens was actually the subject of the very first video I released on this channel. It's because there are just no real financial or criminal consequences for this crap. The stock market may or may not eventually change its mind about punishing stocks for things like this, but don't count on it. And the government may or may not change its mind about enacting legislation about this, but don't count on it. And that means that it's up to us, the technical folks. Now, we can't fix everything on our own, but we can argue for it. We can present our bosses with proposals and solutions for how catastrophic failures can be made less likely. The bare minimum is making sure that we have thought through the technical problems and identified the kinds of places that these issues can happen. That we've done some research on potential solutions or at least strategies, and we've made sure that the people around us are aware of the risks and the options. We should also make whatever changes or improvements we can on our own. I had a very technical boss years ago who used to talk about what he called a keyboard veto. So management can tell you what they want you to do, and they can fire you if you don't do what they want. But they can't make you type code you don't want to type. Now that might result in you having to find another job, and that stinks, no doubt. But so does knowing that tens of thousands of airline passengers and hospital patients are unable to get what they need, and you might have been able to do something about it, but you chose not to. Now, I've fought with management several places and several different times. Often I've won, sometimes I've needed to find other places to work. I'm not saying quit on the spot without having another job, although I have done that. But know when it's time to start looking. Your mileage may vary, but I've never regretted having left a job when my values didn't line up with those of management. There have been a few times that I've shut my mouth, kept my head down, and stayed put, at least for a while. Every single one of those, I have ended up regretting. And that's the second biggest reason that catastrophes like this happen. Because technical people, especially the senior technical people, won't take responsibility for the projects that they're working on. Sometimes this is because they really need the job to feed their families and they haven't found another one yet, and I get that. My sympathies, best wishes, I hope you find something else soon. But that's not everyone, and it tends to be less true the further in your career you get and the more senior you are. Sometimes it's because the programmer is early in their career and the job is good experience even though it stinks, and I get this. Junior developers can't be expected to know all the ways that things might go wrong. But for you juniors out there, that's not a get out of responsibility free card. You should still spend time thinking about what could go wrong in the code you are working on, even if it's only sub part of the system. And you should pay attention to bugs as they're reported, whether you were involved in that part of the code or not. And you should learn from them, because if you stay in this business, either as a programmer or as a manager, you are eventually not going to ethically have the "I was too inexperienced for it to be my fault" excuse anymore. And that will probably happen sooner than you're comfortable with. But a lot of times, neither the "I haven't found another job yet, but I'm looking," nor the "I'm still learning" excuses apply. And it's because the programmer or the technical manager should know better, but they just don't care enough to do the right thing. And oh boy, have I worked with some programmers and managers like this. But if I start that rant, by the time this video is ready to publish, no one will still remember that this outage even happened. I spent a lot of time at the end of my last video talking about programmers who want to spend all of their time on less important things like solid or design patterns and don't want to spend their time caring about errors or caring about the users. And a lot of managers and product managers are the same way. They want to spend their time on new features and avoid caring about errors or the users. And if that's you, if you don't want to care about errors or users, then you can stop watching now. The rest of this video is about technical solutions to actual problems. I often say it's a waste of time to attempt technical solutions to personnel problem. And if you are the personnel problem, then this channel is not for you. Bye-bye, go try a priest or something. Still here? Good. After my last video, I was asked a lot about resources on error handling. Unfortunately, I don't know any really good ones, or even kind of good ones. Part of the problem is that there are no really universal solutions to all problems. But last week we got a really good example of a problem that we can discuss, so let's do that. Buckle up. Now, at the time of this writing, we don't actually know what the actual code problem was in the Crowdstrike driver file that caused the problem, but I don't care. Because statistically, most of you probably won't be writing that kind of code, so it wouldn't be useful to most of you anyway. But that specific code bug, whatever it might have been, was only the first domino to fall in a giant tragedy of errors that led to this disaster. And it's probably the least useful thing to use an example to extrapolate from. Now, the next domino to fall in the chain of things we'll learn from is what I call, "but it works on my machine." I'm giving the programmer of the driver the benefit of the doubt for the moment and assuming that they at least did run the code that they wrote, and that it at least didn't blue screen on the machine that they ran it on. And if that's true, then logically, the problem exists at the intersection of the code that was written and some difference between the environment the programmer ran it on and the machines in the world that blue screened. It's not unusual for your software to work fine in isolation, but when run on a PC with other vendors' software also running, it could fail spectacularly. Now, you web people, same thing can happen when your JavaScript code runs in a browser that has a particular extension running, or when your site is running in an iframe or something and it's embedded in another site that uses the same JavaScript library that you're using, but a different incompatible version. Now, the first thing to say about this is your unit tests cannot help you here. Because by definition, a unit test isn't going to be able to reproduce a blue screen of death. Developers that are like, "my unit tests are passing, so it can't be my problem," are infuriating. I've seen developers that only cared about trivial unit tests that were more mocks than actual logic, and were screenshot comparisons between the UI for this page for this build and the UI for the same page for the previous build, and who actively resisted any attempt to expand the test suite. Those people and the managers that enable them are a stain on our industry, and they give all of us a bad name. Which means if you only care about unit tests, then you don't care about the kinds of problems that cause this catastrophe. Not that I needed yet another example to throw in the face of the unit test uber alles people. but there you go. Some of you might be getting smug now because you only do web stuff, so blue screening isn't a thing your code can do. To you, I have two things to say. First off, over 35 years, I've seen technology after technology become obsolete or go out of favor or get so many practitioners that it was impossible to stand out. And the people that didn't adapt got sidelined. And you don't want that to happen to you. So learn things outside your specialty. You may need to change specialties at some point. And two, there are still going to be things in this discussion that have analogs in the web-only space, and I'll mention a few of them as we go. You might be surprised at the kinds of unhandled exception crash loops I've seen in web server processes that took out all of the members of a large cluster one at a time until the entire service was off the air until we could deploy a patch. Or the number of JavaScript "this page is not responding" bugs that I've seen that only happen in the wild and not in dev environments. So this can happen to your web devs too. Not across the whole world probably, but it can still happen to you. Now you'll notice, if you think about it for a sec, that the "but it works on my machine" problems can't be identified on the developer's machine, kind of by definition. So how can you test your code for that kind of thing? So first off, there are a bunch of different cloud services that let you run code on a bunch of different device variants, different hardware, different OSs, different browsers. I'm not going to recommend any particular one of these services because your mileage may vary, your use cases might vary, and even the ones that I've worked with that I liked might not be any good anymore. But that's one option. Those services do exist. I have used them and I've had good success with them. There are a number of roll your own integration test kinds of products. There are ways that your team can automate kinds of testing. I've done a lot of work in the past of building out test labs and that kind of thing. And note that this does require more skills than just coding. Deal with it. That's not my job, is no consolation to the people affected by last week's crash. Now, I don't know what your part in a particular process should be, but figure it out and do your part. Unfortunately though, even if you do a lot of work to test your product or service in different environments, and you should, you likely can't cover every possible permutation, and no test process is perfect. So assuming that you might miss something, what are your options then? One thing to do is to write integration tests that force failures to happen. Tests that intentionally read in bad files, tests that throw arbitrary exceptions, tests that intentionally dereference and access bad pointers, and make sure that those errors are handled in safe and competent ways. This is a point I cannot stress enough. You should always assume that any particular part of your system can fail, and you should engineer the rest of your system so that when that failure happens, the end result will not be catastrophic. Fail safe is a maxim you've probably heard. Other ones are defense in depth or belt and suspenders. They're all about making sure that failures in one part of a system are compensated for in other parts of the system. That was obviously not done in this case. So what could have been done? What techniques would have helped here? One thing is a slow rollout. Crowdstrike could have only distributed their fix to a small subset of customer machines, waited to make sure that those didn't have issues, and then roll out to more machines and etc. until I got through everything. Same thing for web stuff. I've done a lot of deploy the new server version of the code to only one server in the cluster, wait for a while, compare logs and statistics, make sure it's still behaving, and then start deploying it to the rest of the server. That's really important on mission critical web apps. If that had been done in this case, there still would have been some people that were inconvenienced, but only a few, and it definitely wouldn't have made the news. Now that presupposes that you have some way of monitoring the health of your software. Make sure that you do. Assuming that either a user doesn't explicitly opt themselves out, and making sure you protect their privacy as best you can. And make sure that that health monitoring for your software includes log monitoring, and make sure that your system logs errors in such a way that log monitoring can collect and forward them someplace that can be accessed by your team. Make sure that your code does not fail silently. No if statements or case statements without at least exhaustive logging. If there's an if, it ought to end with an else. And if you don't know what else to do in the else, log something that will show up in the log server so that you can know that that happened and that you know that you need to deal with it. And then once those errors show up in the logs, follow up on the errors in the logs. The number of times I've seen companies that go through all of this trouble to get infrastructure where all of these logs show up in the server and then nobody pays attention to it is just ridiculous. And when your app logs errors, and those errors end up in your logging infrastructure, it's not the IT guys or the DevOps people who are best positioned to or should be responsible for interpreting those errors. That's on you. You know the code, and you know what those errors mean, and you know what to do about them, or at least you're best positioned to. Speaking of parsing and logging, you should always sanity check files that you load before you start executing them, and log an error if those files have some kind of issue. I'm guessing or at least hoping, that a sanity check was actually run on the .sys file in this case, but the check was just not sufficient. Figuring out what sanity checks to run and how can be tricky, but you'll be able to figure out many of them. And a lot of other people have done similar things, and you might be able to learn from them, and you'll learn more over time. Which reminds me, you need to be very vigilant in noticing and tracking down bugs as they pop up. I've personally found and fixed several intermittent bugs in systems I didn't write. Some that had been around for years, because when I see something misbehave, or even something I don't expect, I stop, capture everything I can right then, and make a note so that I always come back to it later. If you see something weird, and then like most developers, you just rerun it to see if it happens again, you may have just lost a rare chance to see a bug being triggered in your system. And having lost that chance, you've also lost your chance to fix it until you or your users have it happen again. Another thing, if you have really complicated file that gets updated regularly, like these Crowdstrike sys files are, put the code that parses them and runs them in a separate process than the one that, if it crashes, will blue screen the entire machine. That way, when something goes wrong, the damage is limited. Another thing that could have been done was to minimize the code that ran at boot time, or that ran in kernel space with unrestricted access to the system. It would almost certainly have been possible to design this system so that if a file was bad or corrupted, the system could have failed without taking all of Windows down with it. Keep in mind that whatever critical things your code has to deal with, and anytime there's something that would be a nightmare for the user to fix if it goes wrong, make that code as simple and well tested as you possibly can. In my career, I've almost certainly had more downtime due to bugs in really complicated high availability systems like load balancers or RAID software or database failover packages than I have by simple hardware failures. Now, partially that's because I've had many hardware failures that were actually handled correctly by the HA software and the RAID software, but also because when HA goes wrong, it tends to go really, really wrong. So when you have something in your system that, like those high availability packages, will go really wrong, if it goes wrong at all, make it as simple as you possibly can. Likewise, make sure that your processes only have the permissions that are absolutely required to have, and no more. It's convenient to just throw all of your code into one big monolith and run it all as the super user, but that's an unnecessary risk. Do the work, do the actual work to separate the concerns to limit what can go wrong. For those of you who are more web cloud inclined than OS inclined, the equivalent would be to put the complicated, risky stuff, the stuff that can lose data, put those in their own microservice instead of being part of a giant monolith that talks directly to the user. That way, if the really complex thing crashes, you can still return an HTTP 500 to the user. You can log the data that you sent it to cause it to crash, and you can notify something that something is wrong. But the most important thing that could have avoided this problem isn't Crowdstrike's fault. It's Microsoft's. Because why is it okay for a system to make a change to a critical code like drivers via a mechanism like Windows Update, which is well understood, and then reboot and fail and crash and then loop crashing over and over and over again? This is a flowchart from the Slim bootloader documentation. This is an open source project for, among other things, updating firmware on Internet of Things devices like light bulbs and thermostats and smartwatches and stuff, and rolling back to the last known good state in the event of a boot failure. With firmware, you kind of don't have a choice because the device out in the field, be it a smartphone or a smartwatch or a thermostat or whatever, doesn't have a console where an admin can boot it into safe mode to fix it if it goes wrong. But why is it that an open source group can write a code base that can checkpoint, update, and roll back changes in the case of boot failures, but Microsoft can't do that for Windows? I can think of no technical reason. So this sounds like a personnel problem, or at least a prioritization problem. As with a lot of things, and I advise you to pay very close attention to this part, someone else had already recognized that this problem exists. They've documented it, they've potentially made a standard for it, and they've provided at least one implementation that deals with it correctly. This is the most widely applicable piece of error handling advice I know to give. Go through the effort to think hard about the things that might go wrong in your system or subsystem that you're working on. Then search for that kind of problem and see what potential example solutions or standards already exist, and then see how those can be adapted to your situation. So let's recap. 1, unit tests works on my machine, not good enough. 2, test on as many permutations as you can. 3, expect that you'll still miss things. 4, plan for failures in one part of your system to be caught and handled correctly in other parts of your system so the whole thing doesn't crash. 5, write integration tests that force errors and make sure that they're handled correctly. 6, do slow rollouts. Don't pull all of your changes to all of your machines at once. 7, forward logs from your applications to a central location and then monitor it. 8, make sure your code never silently fails. Log everything that's not the ideal path, protecting the user's privacy, and make sure it shows up somewhere and then pay attention to it. 9, when I say pay attention to it, I mean you, the developer, need to pay attention to it. Don't just leave it to the IT guys. 10, sanity check all the files before you start running them. Expect them to be bad sometimes, especially the ones that get updated over the air, and compensate for that. 11, be vigilant and persistent when unexpected things happen. Never just run it again. Make sure you know why whatever went wrong, so that you can fix it if it's something that you need to deal with. 12, separate concerns. If there's code that's more likely to crash, like stuff that parses outside files, put it somewhere that the crash can be handled by code elsewhere. 13, anything critical path, like anything that would make a machine blue screen, should be kept as simple as possible. 14, code that has to run with high permissions and can do lots of damage if it goes wrong should be as minimal and simple as possible. Move anything complicated to different processes, threads, or modules, where if something goes wrong, it can't destroy the entire machine. 15, when incorporating patches or updates, assume there may be an issue and have a rollback strategy in case there's a failure. 16, think about the things that can go wrong in your code. Find any discussions about those problems, and especially standards intended to help. Learn from those things. They're there for your benefit, and implement them if they make sense in your environment. Now, I realize that the error handling as discussed in this video wasn't really technical at the level of individual code examples, but that's kind of par for the course for error handling discussions outside of specific low-level context. Hopefully that will make this video more useful to a wider audience. I've got some plans for getting more language and situation-specific error handling videos in the future, but we'll have to see if they turn out okay before I post them. But before we go, I have one more thing I want to make sure I've emphasized. AI can't do any of this and won't be able to anytime soon. In the context of a specific error case in a specific code example in a specific language, there's a chance that AI could write the code to handle that error case correctly. Right at the moment, such a hypothetical AI would probably not do a great job compared to a senior developer. But the AIs will get better and better at that over time. And if living inside a code editor is all you care about, then you're sitting right in the bullseye that the AI companies are targeting, which is the well-defined problem in a well-defined space using well-defined tools. Most of what this video discussed is very likely to be out of reach of any kind of AI product for the foreseeable future. It may be true at some point that AI will be able to take a given code base, figure out what is the worst thing that could go wrong, figure out what is the best way to mitigate that scenario, and implement a competent solution. I expect that will be decades from now, but who knows? But at that point, AI will be able to replace every middle manager in every industry, and developers will actually be in much better shape than a lot of people. So I encourage you to lean into thinking about the kinds of errors that exist in your system. What can be done about them? Fix what you can on your own, and advocate on behalf of your users to try to get your management to do the right thing. Sometimes it may make you unpopular, but your conscience can be clean. You'll be learning skills that are far more likely to be useful and remain useful, instead of restricting yourself to things that the AI companies are actively working on trying to replace. So until next time, never forget that the internet is full of bugs, and anyone who says different just cares more about themselves than the effect that bad code and bad software has on the public. Let's be careful out there.